So the good news about today is that you kind of already know how to just do most of this. There's one little trick though with it. Now you know how to solve multi-step equations, right? We just did a whole bunch of those, okay? So let's just talk about, and in order to get to multi-step, we're going to build our way up there. We're going to start out very simple. This is probably a 5th or 6th grade equation here. And what this means is that if I were to solve both sides for x and subtract 3 from both sides, I'd find that x equals 2. It has to equal 2, and it cannot equal anything but 2 because that's an equal sign. The only value that x can be is 2. It can't be 2.1 because then that's not equal to 5. It can't be 1.9, so that's the case there. But today, let's replace that equal sign with an inequality sign. And let's see how that affects our answer. The good news is it doesn't change how you solve it. You still use inverse operations. You're still going to add 3 to both sides. This becomes x is greater than or equal to 2 now. Instead of x equaling 2, this means that as long as you give me a number that is greater than or equal to 2, you're good. If I put it in for x, you'll be okay. So let's take 2, because it's equal to 2. Is 2 plus 3 greater than or equal to 5? Yes, it's equal to. 8. 8 plus 3, that's 11. Is that greater than or equal to 5? Yeah. So let's think of a number. So today your answers are going to be solution sets and not just one number, okay? So 1. Is 1 greater than or equal to 2? No, it's not. We know it's not in that solution set. Let me prove it to you. Because when I put it here, 1 plus 3 is 4, and 4 is not greater than or equal to 5. So that's how you know that your solution doesn't satisfy that inequality. So pretty much, here's what we're learning today. We're going to learn 1 step, which we just did. And then I'm going to show you right away 2 step, which takes us then to multi-step. And then the last thing we'll end up on is variable on both sides. This is the these are the 4 basic categories. I kind of feel like we don't need a whole day of just 1 step or a whole day of just 2 step. Because this is an advanced algebra class, you should already know how to solve all these with equal signs. So today we're going to do all 4 with inequality signs. So that was just a 1 step, okay? Let's take a look at what like this would be. A divided by 5 minus 1 is less than negative 1. Okay? So I'm still going to add 1 to both sides. Add 1 to both sides. A over 5 is less than 0. Be careful. Like everybody kind of seems to think if 0 is somehow in their problem, they're like, oh, no solution, can't do it. 0 is an integer just like all the other ones. This time I'm just going to multiply by 5. And what's 0 times anything? 0. So this means any number greater than 0 will work. 1. 1 divided by 5 minus 1 is less than negative 1. 10. Or I'm sorry, it's got to be less than 0. So negative 1, as long as they're negatives, okay? Negative 10. Negative 10 divided by 5 is negative 2. And negative 2 minus 1 is negative 3. Is negative 3 less than negative 1? Yeah. So that's how you can check your solution set. Good? Okay. So now let's get to the twist. Because you're like, whoa, so that's all we're doing is solving the same thing except with inequality signs instead of equal signs? Yes, all except for one little thing here. So I'm going to show you 2 problems. I have 5a is less than 30 versus negative 5a is less than 30. And we're going to solve both of these. And actually, let's do this one. 5a is less than negative 30. So they all kind of look like the same problem. Except this has no negatives, this has 1 negative, and this has 1 negative. So let's just solve this. 5 divide by 5, right? The division property of equality says to do that. So I found out that my solution set is all numbers less than 6. What's the first whole number less than 6? Let's take 5. Is 5 times 5 less than 30? Yep. 2. Is 5 times 2 less than 30? Yes. Let's take 6. Is 6 times 5 less than 30? No. So that's why 6 isn't part of your solution set, right? Okay. So I'm going to do something wrong here. So I just want, if you already know this lesson, -6. So we're going to work on something here. So give me a number less than -6. Meaning, look at the number line. You're getting farther away from 0. So you're going to the left. Less than -6 would be? -7. So let's see. If I plug in -7 here, I should get a true statement. But I don't. Because 35 is not less than 30. So something's wrong. And what's the only difference in this problem than this problem? Everything is identical except what? That negative. Okay? So if I had to leave the 35 and the 30 here, what could I do to make it a true statement? Yeah, just switch the direction of that. So you're saying if I took this and switched it and made it this way, then is it true? 35 is greater than 30? Okay. So let's do this problem next, and then we're going to talk about what this has us discover. So somebody said, actually before I do this problem, somebody said, I think you're supposed to switch the sign around, the inequality sign, when there's a negative in the problem. Okay, there was a negative in the problem. I switched it around. So technically, if there's a negative in the problem, they're thinking this. So watch. A is less than -6. Give me a number less than -6. -7 is 5 times -7 less than +30. That's true, isn't it? Did I need to switch it though? No. So I didn't switch it here. I didn't switch it here, but I did switch it here. Why do you think that's the only one I had to switch it for, Kayla?
Because when you multiply and divide by the number, you have to.
Yes. She said exactly what I wanted her to say. Because here, the number that I divided by was negative. Here, the number that I divided by was positive. Positive. So, the multiply, if you multiply or divide by a negative, then is the easiest way to say it for you guys to remember it just be to flip it. Do you know what I mean by flip it? I don't want you to think reciprocal or anything because that's the term. You switch the sign around, the direction of the inequalities, right? So switch it. Okay? So that is the one thing that you have to remember. Otherwise, everything else is the same. So let's take a look at some more problems here. Everybody got that? If you multiply or divide, not if there's a negative in the problem, right? So if I have x over 3 plus 7 is greater than or equal to -2, and negative x over 3 plus 7 is greater than or equal to -2. Okay. What's that? Yes, when it's either a coefficient or underneath it that's being multiplied by. So this one, -7, subtract 7 from both sides. X over 3 is greater than or equal to -9. Am I going to have to switch the sign around, flip the sign on this one? No, not because the -9, fine, that's fine. What I'm doing right now is multiplying by a positive, and if you multiply by a positive, you're good. So x has to be greater than or equal to 27 to be put right here, and then all those numbers will satisfy that inequality. Now, I did this next one on purpose because as you're looking at it, you're looking at a 3 and you're seeing that the 3 looks positive, right? But here's what I need you to remember. Remember where I said about negatives? Negatives can be anywhere. They can be in the numerator. They can be in the denominator. They can be in front of the fraction. The x is not separate from the 3. Actually, there's a 1 in front, so this could also be written like that. Did you know that? So x over 3 is the same as 1/3 x. And guess what? This whole amount together is negative. So if even though the negative is not on the 3, I'm still going to have to multiply by a negative 3, right? Okay? So this gives me negative x. Actually, let's subtract 7 first. That's going to give me negative x over 3 is greater than or equal to negative 9. And I had a great question last hour. Can you, once you look at it and see that you're going to multiply by a negative or divide, can you flip it right away? I don't want you to flip it until you do the actual act of multiplying or dividing by a negative. So here, I'm multiplying by a negative 3. And because, even though it's there, that's okay. So that's x, not greater than or equal to now, but less than or equal to. And if you forget to flip it, that is going to affect your answer. So if you forgot to switch it, you may have drawn your arrow this way, but in reality it should be this way. And those are really easy for me to catch, because when I see your arrow going the wrong way, I'm like, they forgot to switch it. Okay? So let's take a look at this next one here. So let's take 4x minus 2 less than or equal to 7x plus 8. Okay. So as I'm looking at this, you can control a lot of things yourself, right? So you may say, oh, I always like that variable on the left-hand side, which means I'm going to subtract 7x from both sides, but that's going to leave me with what? A negative coefficient, which is okay as long as you know that you're going to have to. I'm going to show it to you both ways, actually. Negative 3x minus 2 less than or equal to 8. Then you're going to add 2 to both sides. And that's going to give you negative 3x less than or equal to 10. Now, I am in the act of dividing by a negative right now, so now is when I would flip it. So x is going to be greater than or equal to negative 3 and 1/3, right? So I had somebody then say, well, if you just put the x's on the right, then you don't have to worry about flipping it around, right? Are you able to kind of see that? Because if you subtract 4x from here, then you get negative 2 less than or equal to 3x plus 8. And then minus 8 gives you negative 10 less than or equal to 3x. And then when you divide by 3, you didn't divide by negative, right? So don't switch anything. Leave it like that. It's still negative 3 and 1/3. But the dilemma in this case is that now what? Those are the exact same answers. But if you're being asked to then graph this, remember we talked about when the x is on the right, it's kind of confusing. So you're looking at a big old less than sign, meaning negative 3 and 1/3 is less than or equal to x, which means that x is really greater than or equal to negative 3 and 1/3. So here's what's kind of confusing about all this flipping around. Because if you're looking from this step to this step, it looks like, where are we at? Oh, from here to here. It looks like you may not have flipped it around. So, looking at this, you have to know it's like we flipped, oh, never mind. That would be if we flipped it by a negative. So does everybody kind of see what this is? And the way I explain this kind of is, either if you're going to flip these around, you have to switch the sign. So, same answer. So it's like you have to deal with one of the two evils. You either have to deal with flipping it around when you divide by a negative, or flipping it around because the x is on the right-hand side. It shouldn't matter, whichever way you're more comfortable with, okay? So, let's try this one. Negative 4 times x minus 1 plus 3 is less than or equal to negative 2x minus 5. All right, so go ahead and work through that one, and let's see if you can get the correct answer. When you're ready, you can look up. I'll start to do some steps slowly. Good. Did you remember to flip it? Because if you forget to flip it, it changes everything. It changes your graph. It changes your list and all those things. Okay? Are we okay with this? Did anybody put the X's on the other side, on the right-hand side? Okay. So that's okay. However, yeah. I mean, you could have done it either way. All right. So are we comfortable with this? And enough to just know, basically it's the same steps of everything. The only other thing you need to worry about is when you get to the very end. If you multiply or divide by a negative, you need to flip the direction